Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 6th grade topic, ratios and proportions. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. Now, if you have any questions about what we see here today, or even your own homework, you can always put them in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. Today's video should have some pretty interesting concepts, especially with some visuals to try to drive home our point. So stick around, hit that like, smash the subscribe button, and let's get started. So to begin our talks on ratios, you first have to ask the question, what is a ratio? Now, you might see a bunch of different definitions about what a ratio is, ranging from comparing different items or, let's say, a relationship between two entities or more entities. But I'm going to do something and try to simplify a little bit. And I'm going to call it, you're identifying the pattern between different items. So for example, let's say we have red lights and blue lights. And the red lights and blue lights are arranged in the following way. So you have a red light, and then you have a blue light, and then you have a red light, and then you have a blue light, and you see this continues. So we're going to just alternate between the red, and this is kind of like a orange light, but whatever. A red light and a blue light. All right, and one more. We have a blue light there. So this is our set of lights. You know, we have red light, blue light, and so forth. Now, what is the pattern that you see here? You see, it seems like after every red light, there's a blue light, right? And then after every blue light, there's a red light, and that continues. Well, that's the pattern. If you were talking about ratios, you would then say for every red light, there is a blue light. That's it. For every red light, you have a blue light, right? And that's true. If you look at this red light, you have a blue light. This red light, you have a blue light. This, there you go. This one, there you go. There is no red light without a blue light. That's all a ratio is. You're trying to identify the pattern that you have between different items. However, your ratios can change. So let's say this was arranged slightly different. Let's say instead of alternating, you had something like this. So you had, instead of after every red light, you had 2 red lights and then a blue light, right? So we're gonna keep that going. 2 red lights. Oh, I said 2. And then a blue. 2 red lights. And then a blue. Now what do you see? Well, we've already talked about what the pattern is, right? However, how do you say this as a ratio? Well, you're seeing after every 2 red lights, you have 1 blue light. So instead of after every red light, you have a blue light, after every pair of red lights, you have a blue light. That's all a ratio is. And I wrote it this way so you can easily see the ratio, but let's say I wrote it this way. Let's say instead of having it alternate like this is what you have. Well, it's going to be the same exact ratio because this is just simply an arrangement of what you already have. The same items are here that are here, right? You have 1, 2, 3, 4, 5, 6 red lights, 1, 2, 3, 4, 5, 6 red lights, and you have 1, 2, 3 blue lights. 1, 2, 3 blue lights. So a ratio is quite literally something that you can look at a glance and have an idea of what kind of pattern that you will have or how the items are related. Remember that relationship. So it doesn't matter if you have an actual pattern written out. Look at this and you can say, I have 6 red lights and 3 blue lights. That means for every 2 red lights, there is a blue light. If I was to try to pair these off, you know, this goes to that one. These go to this one. And these go to this one. See, each one gets its own shape. You can pair them off. So it doesn't matter if they're written out like this or like this, the ratio stays the same. This is simply an arrangement, but your pattern is there. Sometimes it might just be a little harder to find the pattern, but it's there. That's all your ratio is. So we know what a ratio is at this point. It's just our pattern that we identified from our different items. However, how do you write a ratio? Well, there's a lot of different ways to write a ratio. And some of them you've probably seen already, and some of them maybe not. Let's say you had this ratio here. So we have, let's say, 5 peaches, for all those fruit eaters out there, 5 peaches and let's say 3 apples. And they want us to find the ratio between the peaches and the apples. So you can write this a few different ways. The first thing you have to figure out is, where's your focus going to be? Are you going to focus on the peaches or the apples? Because that matters. Your focus matters because that's going to determine how your ratio is going to look. So let's say our focus is going to be the peaches here. Well, it says for every 5 peaches, we have how many apples? 3 apples. So our ratio will be 5 to 3, or 5 to 3. Or 5/3. Or you can say 5 peaches for every 3 apples. Notice that the first number pertains to your focus item, your peaches in this case. That's why it matters where your focus is. These are all saying the same thing, whether you use a colon, whether you write out to, whether you use the fraction form, or you write out as a sentence. They're all saying the same thing. You have 5 peaches for every 3 apples you have. But let's say your focus changed. How does your ratio change? Let's say instead of focusing on peaches, we want to focus on apples. For every 3 apples, how many peaches do we have? Well, if you're going to change your focus, we have to change our ratio form. Now, the ratio idea is still the same. You're getting the same information, you're just changing the focus. So you're going to see the same numbers. Instead, going to be in different orders though. So 3 to 5, 3 to 5, or 3/5, or 3 apples for every 5 peaches. Figure out where your focus is. Depending on where your focus is, that's going to determine how your ratio looks. But you can write them in a lot of different ways, from your colons to simply writing out to, or simply writing out everything, or even this, your fraction form. Now, fraction form is going to be something that we'll use a lot, especially when you start talking about proportions. The fraction form of ratios is very, very useful. And it mainly shows up when you have 2 items. Now, you can have way more than just 2 items that you're comparing for your ratio. How would you write if you have 3 items, for example? Let's say you have a crowd of people. And in that crowd, there are, let's say, 2 men. Let's say there are 6 women. And let's say there are, 3 kids. How do you write this in ratio form? Let's figure out our focus for this one. Let's say kids are going to be our focus. Well, that says for every 3 kids, you have, let's say, 2 men and 6 women. You can also say 3 to 2 to 6. Or you can write out the whole thing. It's going to be a little long, so I'm not going to do that one. But this is probably what you're going to see more often. Colon form shows up a lot more, especially when you have more items. But one cool thing about your ratios is similar to how your fractions, remember you can write your ratios as fractions when you have 2 of them, but similar to how you can change your fraction form, you can reduce it or you can increase it without changing the value. You can do the same thing for ratios without changing the ratio. Let's say instead of 2 men, we had 9 men. So that 2 goes away. And we don't need to look at this right now. We're just going to focus on the colon form. So your ratio now is going to be 3 to 9 to 6. Well, you can leave it like that. That will be fine. You can leave it like that. However, we like to reduce our ratios whenever possible. Similar to how you reduce a fraction, you can reduce a ratio. By finding the greatest common factor of all of the numbers, you can divide each number by that GCF. And then when you do that, you reduce the ratio without changing its value. What's the greatest common factor of all of these numbers? 3. 3 goes into all of them, and it's the biggest thing that goes into all of them. And when you divide everything by 3, this ratio reduces down to 1, 2, 3, 2, 2. So this ratio means the same exact thing as this ratio, except it's reduced. So we've talked about what a ratio is, and we've talked about how to write them. Now we're going to talk about some examples. Pull the ratio out of random things in life that we may come in contact with. However, in order to really do that, I have some visuals that are going to help us. So the other day, I was reading this martial arts manhwa, and it's called Gosu. Now, Gosu is an amazing work, and I really love the fight scenes. If you never read anything like this, or you do read these kind of things, but you haven't read this one in particular, I recommend it. Read Gosu. It's really good. However, I got to this chapter in which this page talked about a war, and it got me thinking, hey, I'm going to be talking about ratios this weekend. And war is definitely where ratios comes into play a little bit more. Without having to look at the entire set of numbers, ratios can give you at a quick glance how devastating that war really was. And I was reading this and I thought this would be a perfect example of real world uses of ratios. This chapter had this page that talked about a crazy war, and it says, but the victory also left the alliance in tatters. For 8 out of every 10 men who'd taken part in the struggle perished. Now that says something to me. And it should say something to you as well, because that tells us just how crazy that war was. We don't know how many people actually participated, but there's a ratio in there that can give us an idea of just how bad it really was. But we have to see who are going to be our players that are going to be part of our ratio. It looks like it's just going to be men, and that's only one. You can't just have one when you have this relationship here. So what are going to be the players? What's going to make up our ratio? Well, if we take a closer look, there are actually 2 things that jump out. Men who perished and men who had taken part. So the first thing we see is actually going to be the men who took part in the war. And the next thing we see are going to be, unfortunately, the men who died in this war. So now that you know who the players are, what is the ratio that you can take out of this? And remember, it says 8 out of every 10 men who had taken part had actually perished. So how many people took part? How many people actually participated in this war? Well, 10, right? 10 people took part. And of the 10 people who took part, how many of them died? 8. Well, it seems like for every 10 who took part, 8 perish. So if we're going to be focusing on those who participated, that's our focus point, our ratio is just going to be 10 to 8. But we can reduce this to something else. Greatest common factor here is going to be what? 2. So we can divide everything here by 2, and by doing so, we change this ratio, instead of 10 to 8, 5 to 4. Now we have a pretty solemn picture of how devastating this war was. But we don't need to know the exact numbers on who fought and who died. Ratios give us a good understanding, just at a quick glance, just how devastating it was. But ratios have a wider use than just figuring out how bad a war was casualty-wise. So let's look at another way ratios are used, and let's have a little lighter background than this doom and gloom war setting. Let's say we're going to be baking something much cleaner than the whole war scenario, right? But baking is something that ratios also play an active role in. And even if you don't bake, you might like the baked goods, right? So realizing that ratios play a part in almost everyday life, because baking happens pretty much every day somewhere. In this case, we want to bake a cake. And in order to bake a cake, you're going to need ingredients. So let's say you were baking a cake one day and you looked up ingredients for this cake and you found this list. Now, this is a pretty decent sized list. So let's ignore the baking powder and the vanilla extract. We don't need that. But we're going to focus on the rest of the list. Now, the rest of the list tells us we have butter, we have sugar, we have some eggs, there's cake flour, and there's some milk. And if you look closer, these ingredients start looking a little ratio-y. Now, I know that's not a real word, but kind of go with me here. I'm starting to see the makings of a ratio here, right? It says we have 1 cup of butter, 2 cups of sugar, we have 4 eggs, 3 cups of flour, and 1 cup of milk. If I was to try to formulate the pattern here, what would be our ratio that we can come up with? Let's say our focus point is the first thing we see, the butter. For every 1 cup of butter, we have 2 cups of sugar, 4 large eggs, 3 cups of flour, and 1 cup of milk. So we can write this in our colon form as 1 to 2 to 4 to 3 to 1. So you see, this big ratio is pretty much all you need to bake a cake. Just understanding that each one of these, except for the 4 eggs, pertains to a cup, then you can easily bake not only 1 cake, you can bake more than 1 cake. Let's say you wanted to bake 2 cakes. Well, what would be the ratio for baking 2 cakes? Well, would you have to recalculate everything? No, because the ratio won't change. We just want the same exact thing for the next cake. So we're going to multiply everything by 2, and by doing that, we're going to get a new ratio that doubles, right? So we're going to have a ratio that is no longer 1 to 2 to 4 to 3 to 1, but instead it's 2 to 4 to 8 to 6 to 2. And that's going to be our ratio for making 2 cakes. As long as you understand the base ratio, you can always figure out how many ingredients you need for all of your cakes at a simple glance. Let's do a little brief mention of proportions. Now this video is getting a little long, so we're not going to talk a ton about proportions, but I will give you a small little overview of what a proportion is, and then in a later video we'll go a little bit more in depth. Now, your proportions, they're going to be tied to ratios or they wouldn't be in this video. But if you are going to think about what a proportion is, understand what your ratio is first. Now, ratio, like we said, is going to be the pattern or the relationship between different items. Your proportion is actually going to be the relationship between your different ratios. So let's say you have the ratio 2 to 5, whatever that ratio is. Your proportion is going to see how that ratio compares to another ratio. Let's say 6 to 15. Are these equal? Yeah. If you multiply this by 3, top and bottom, you're going to get this answer here. So you see these ratios are equal. Understanding that they have to be equal, your proportions are going to be the next step. You're going to take those ratios and then compare or see the relationship between those. That's what we're going to get into in another video about proportions. So I hope you're able to follow in today's examples, and I hope today's visuals show you just how much of a role ratios play in everyday life. Whether you're talking about the casualties of war and how crazy and deadly that war was, to simply baking a cake and trying to remember how much of whatever recipe or whatever ingredients you need. Ratios are everywhere. If you have any questions about what we saw today or even your own homework, remember, you can put it in the comment box below or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to hit that like button. It really helps the channel by letting YouTube know that you found this video helpful. And if you found it helpful, someone else could find it helpful as well. So leave that like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.